So we had this problem. We wanted to figure out what the limit of just this piece was, knowing that the limit of the whole thing was 1. Now hopefully you got as an answer that the limit was 21. Let's see why the limit is 21. So if we look at this limit, now it's 1, but we also know by our limit rules that the limit of a quotient is the quotient of the limits. So it should be the same thing as the limit as x tends to 7 of the square root of f of x minus 5 over the limit as x tends to 7 of x minus 3. Now let's just work on this bottom part for a second. This is the limit of a difference, and the limit of the difference is the difference of the limits. So on top, I'm going to leave this alone for a second while I focus on what's going on down below. Down below we have the limit as x tends to 7 of x minus the limit as x tends to 7 of 3. And so from here to here we've applied the quotient property for limits. I'll call it the QPL. Now we've applied the difference property for limits to get here. Now these limits down below are easy. Obviously, if our function, if the input and the output are the same, if the input gets close to 7 and the output is the input, then the output is going to get close to 7. So that's going to get close to 7. Of course, this constant 3 doesn't care what x is. If x can get close to 7, if it's like, the output is still going to be 3. So that limit has to be 3. Now up on top, I could make a little bit more progress though. Having a square root is really the same as having it to the 1/2 power. And from our power rule, the limit of the power is the power of the limit. So basically, because of that power rule, I can let this pass inside and focus on this to the 1/2 power. So finally, I've got what I'm looking for involved in the equation, right? What I was looking for is this. I know that the whole limit is this, and it turns out to be 1, and because of my limit properties here, I've been able to show that this limit, which is 1, is the same as that. So I'm going to solve for this, and that will answer the question. So what I've got, if you look at this equation, I've got the limit that we're looking for. The limit is x tends to 7 of f of x minus 5 to the 1/2 power, or under a square root if you like, over, let's see, 7 minus 3 is 4, has to be equal to 1. So let me go ahead and solve for this thing. After all, that's what I want. If I multiply both sides by 4, I get that the limit as x tends to 7 of f of x minus 5 to the 1/2 is equal to 4. Now let me square both sides. If I square the left side, I get the limit as x tends to 7 of f of x minus 5 is equal to 16. If I add 5 to both sides, I get the limit as x tends to 7 of f of x equals 16 plus 5 is 21. So we got our answer here of 21. You can see if you go back up here, if this is close to 21 minus 5 would be close to 16. Square root of some number close to 16 would be close to 4. Close to 7 minus 3 would be close to 4. So close to 4 divided by close to 4 should be pretty close to 1, which is what we found. So nice little check that this limit seems to be right. I was just applying these limit properties to isolate the limit that I was interested in.